So our next speaker is Michael Goldsworthy, who is the Group CEO and Managing Director of SLX Systems. So the slightly different style story to your conventional uranium miner that you're hearing from the rest of this conference. SLX Systems has developed proprietary technology for enrichment of uranium using laser technology, and it's all military grade secret, so we can't exactly explain to you on the call exactly how the technology works. Suffice to say that this is technology that's been in development for many, many years, was almost commercialized 10 or so years ago, but was put on hold given the downturn post Fukushima. And in the interim period, Michael and his team have been further working on the technology. The technology is owned by SLX. It's been commercialized via the GLE joint venture, which is 51% owned by SLX and 49% owned by Cameco, who have an option to move to 75%, which I'm sure Michael will talk about at some point. And it's at a very exciting stage now with a test loop facility being built in Wilmington in the US. We should be hearing results from that test facility in the middle of this year, which then paves the way for a full commercial application of the technology at the Pajikar facility. And one way I think that investors can think about this company and this project is that Pajikar is effectively a 5 million pound per annum uranium mine. So it will be adding new supply into the market by reprocessing spent tailings at that facility, and we'll be doing it in a very cost-effective way. So, Michael, over to you. Thank you for giving us your time this morning, and look forward to hearing the SLX story.
Thanks, Andrew. Can you hear me okay?
Can hear you loud and clear.
All right, and thanks for the intro. I think you've just covered my presentation very well. Thank you very much. I'm going to talk mainly about uranium, but I just want to start by pointing out that we do have the same technology being applied to a couple of other applications, silicon enrichment for silicon quantum computing, an emerging industry that many would have heard of. And then we also have a project in the early stages looking at medical isotope enrichment, first one being ytterbium enrichment for new frontline cancer therapy, in particular already approved in the US, UK and Europe for advanced prostate cancer. So common theme in all these materials is that in the uranium and nuclear fuel sector, Russia plays a major hand and has thereby caused some disruption through impending bans and a move away from Russian supply of nuclear fuel. Silicon enrichment, most of the world's enriched silicon came from Russia, and that's now disrupted. And for medical isotopes for ytterbium, all of enriched ytterbium was coming from Russia. So again, a disrupted supply chain. But let's focus on uranium. We're talking about global laser enrichment, our joint venture with Cameco, 51% owned by SLX, 49% owned by Cameco. And I don't need to introduce you to Cameco, obviously, but they have been a great partner and continue to work with us in commercialising our technology through GLE. We're going to talk about the triple opportunity. Just a brief introduction here. Our first project at this point is the processing of depleted inventories of tails material that went through the US Department of Energy's first generation gas diffusion enrichment plant in Paducah, Kentucky. I'll come to that shortly, but that's our baseline project, if you like. The huge opportunity for GLE is actually going to be in low enriched uranium production. That's fuel for existing nuclear reactors and therefore help with the supply disruptions that are impending in light of the Russian situation. And then thirdly, production of high assay low enriched uranium, HALEU, for next generation reactors, including small modular reactors. The nuclear fuel supply chain includes 4 steps. First 3 on the top line, uranium production, which you've been hearing a fair bit about today through conventional mining operations. Conversion, once the uranium oxide is produced by the miners, it has to be converted to the fluoride so that it can then go through enrichment plants, which are all centrifuged today. And enrichment being the third step is quite a high value step with third generation laser coming from SLX via GLE. And then the fourth step, once the uranium is enriched, it is made into fuel elements, and that's in a fabrication plant, and then the fuel goes into the nuclear power plant. So Looking at today's situation, post-Russian invasion of Ukraine, there's been an over-dependence on Russian-sourced nuclear fuel for 20, 30 years now, and that's causing some quite significant risks. In the conversion industry, there's only 3 Western suppliers if we take Russia out, Cameco, Orano and Combidon. And enrichment, it's even more precarious. There's only 2 Western suppliers of enrichment services today. That's the centrifuge factories run by Urenco and Orano, both based in Europe. Urenco has a moderate-sized plant in the US. There's no producers in the Western world of HALEU, so the US government has been ramping up efforts to spur development on that front. Russia currently supplies around 30% of the European Union's nuclear fuel and about a quarter of the US nuclear fuel requirements. So still a significant contributor. The bans on Russian imports have not occurred yet. They're pending. And we could see action on that front, certainly in the US in the near future. But just to give you an idea of the impact of elimination of Russian imports into those 2 markets alone would cause quite a bit of chaos. That's caused uranium conversion and enrichment pricing to rise quite dramatically, at least doubling, and in the case of enrichment, tripling over the last couple of years. So quite a bit of movement there and more potential movement upwards in those prices to come. Getting back to GLE's operations, we've approved an acceleration of GLE's commercialisation program last year that is continuing this year. So we have a technology demonstration, a huge technology demonstration at full-scale pilot level. So this pilot plant has now been constructed in Wilmington, North Carolina, and is currently going through its commissioning processes. That facility will be in action in the next couple of months. At the moment, it's going through what we call cold tests. In other words, preliminary test without actual uranium feed loaded in. So once those cold tests are all done and we're finished tweaking and optimizing, then we will be introducing the UF6. We just announced this morning that the US Nuclear Regulatory Commission has approved the use of the uranium hexafluoride feed material in that pilot facility in Wilmington. That test program is going to kick off in the next couple of months, and it'll take 3 to 6 months. As Andrew pointed out, it could be sometime around the middle of the year. We think it'll probably take a little bit longer. We're having a third-party independent contractor, engineering contractor, come in on behalf of owners, SLX and Cameco, to do the assessment of that test facility, the pilot plant facility. It's called a TRL6 demonstration, so that will happen all this year. If that is finished this year and other things fall into place, such as market factors and licensing, then we could have the first production occur as early as 2028. In the meantime, US government has rolled out some incentives. There's the Inflation Reduction Act, including $700 million for the HALEU availability program. That program is still alive. It's the subject of two different funding buckets, if you like. The first bucket was to do with HALEU enrichment. GLE has decided that is not the best course for it, and we are now looking at the second bucket, which is $100 million of that $700 million for innovative enrichment technology, and that would be grant funding, most likely, as opposed to offtake agreements under the other bucket. So there are other bills coming through. There was the Nuclear Fuel Security Act that passed Congress a couple of weeks ago as part of the Supplementary Appropriations Bill. That carries $2.7 billion in funding for new fuel cycle production plants. So GLE will be looking at that program as well. And then there is another bill which is currently snared up in the Senate, US Senate, that will ban Russian imports of nuclear fuel into the US. That's already gone through the House of Reps. It's being held up by Senator Ted Cruz because of other issues. So there is bipartisan support for that ban on Russian imports. It's not clear cut when that will go through, but if that does come through, then those bans will come into play over the next 3 months. There will be some waivers for existing contracts, so utilities don't have to switch off nuclear power plants, but that is going to create a lot of upward pressure and tighten the nuclear fuel supply chain quite dramatically. In the meantime, we've had good relations with US utilities. We've already signed letters of intent with Constellation, Duke and Dominion, and there's a couple of other utilities that are lining up to cooperate with GLE as we speak. The timeline that I've already just mentioned, the base timeline, the conservative timeline is shown on the upper part of the chart, showing commercial operations beginning around the end of the decade, 2030. But the accelerated timeline, more importantly, with the demonstration this year of the technology at full-scale pilot level, followed by some feasibility and licensing activities into the middle of this decade, and then engineering, procurement and construction potentially starting to take place in the next 3 years, aiming for initial commercial operations as early as 2028, which is up to 3 years earlier than originally planned in the upper timeline. So that's where we are. This is a huge year for GLE, for SLX, and for Cameco. To get this technology demonstration done means that we largely de-risk the technology at full scale, and so then the focus increasingly turns over to the Paducah project, where we have planned that first commercial plant. This slide just goes through a bit more detail on the test loop facility. So basically, as I said, cold commissioning underway. We've got the NRC approval to load, and the pilot demonstration hopefully concluding at some point in the second half of this year, leading the path clear to focus more on the first commercial plant in Paducah. The triple opportunity, just to go through in a bit more detail. The first opportunity is like a mining operation because we're taking tails material from the first generation gas diffusion plant shown in the top left of this picture here. That plant has been decommissioned as of 2013. The buildings are still there. All the yards around those buildings are full of tens of thousands of cylinders of depleted uranium hexafluoride, which still contain quite good quantities of the uranium-235 isotope. So that's the depleted feed material that GLE has contracted with the Department of Energy to acquire, over 200,000 tonnes of that material. That will come over the fence to our site, which we're securing as we speak. The GLE site will include three different factories, if you like. The blue factory is where we will process the depleted tails material from the DOE cylinders in those yards, and that will then lead to further processing potentially in a plant which will produce low enriched uranium. That's the fuel for today's reactors. We have earmarked 6 million units of capacity for LEU on the left-hand side, and another 6 or more potential units for expansion over on the right-hand side there. So LEU, as I mentioned, is potentially a huge opportunity for GLE, SLX and Cameco. And then out the back here in the green building would be a facility dedicated to production of high-assay LEU. So they are the three opportunities: the PLEF UF6 natural-grade uranium production in that blue building, the LEU facilities in the grey buildings, and the HALEU in the green. The amount of production in that first opportunity producing natural-grade uranium is equivalent to a uranium mine producing about 5 million pounds of yellow cake a year for 30 years. So there's about 150 million pounds of contained resource, by far the largest resource of uranium in the US. So that is our key baseline project that will occur in that facility. I won't spend any time on this flow chart, but it's there on our website. If you want to understand the process flow and the material flow in a little bit more detail, this slide shows you how it goes through the blue building and then through the grey building and what you end up with. So just to recap on the natural uranium production from the contracted Department of Energy depleted tails, akin to a Tier 1 resource. We've analysed the costs in quite some detail. There is an all-in cost that is CapEx, OpEx, sustaining CapEx, project finance costs, payments to DOE for the feed material, all-in costs of less than $30 a pound, so potentially at the bottom quartile of the uranium production curve. And as I mentioned, 150 million pounds contained resource. Not only do we get the value of that uranium that's produced, but we also get the value of the conversion, because our feed material is already converted. That was the second step in the supply chain I showed you, and today fetching about $35, $40 a kilo just for the conversion. So if you add all that up, there's hundreds of millions of dollars of potential revenues just from that first opportunity, which is the blue building to produce natural grade uranium from the depleted uranium tails material. So that, in essence, is the status of things as we stand this year. And right now we have 51% equity in GLE. When we restructured GLE back in 2019, 2020, Cameco requested an option to acquire an additional 26% at fair market value, in which case, if that was exercised, SLX would go from 51% to 25%, and Cameco would go from 49% to 75%. That window has been open since last February and closes 2 or 3 years down the track. So either way, whether we're 51% or 25%, we have a significant stake in GLE as an equity owner, and there will be obviously potential distribution of profits down the track there. Second bite of the cherry is through our technology license, which has been in place. GLE is the worldwide exclusive licensee of the SLX technology since 2006. And that license brings a very attractive royalty of between 7 and 12% of GLE's enrichment SWU revenues. And we just give a quick example here. If we're operating the blue building and the first grey building in the picture I just showed, it's about 8 million units equivalent enrichment production. And that would bring a royalty of around $80 million at 7% royalty rate at today's enrichment price. So the royalty itself is very valuable to SLX alone. And so that is our uranium update. I might just pause there and see if there's any questions.
Yeah, terrific, Michael. Thank you for that. Yeah, a quick question on this, the option with Cameco. You know, obviously this is a very difficult asset to value. You know, the uranium market itself is difficult to pin down, and with a new technology like this, difficult to you know, to value. How do you go about coming up with a market valuation for that option value between yourselves and Cameco?
Yeah, so just by way of example, to look at the valuation on that first step, so taking the depleted Department of Energy tails, taking it through the first haul of process equipment. It's the same lasers, same separators that would go into all these buildings, but just set up slightly differently. So that will produce around 5 million pounds a year equivalent of natural uranium production. So at today's price, you know, $80, $90, whatever, there's, you know, $450 million of revenue there, US. All this is US. And then we also get the value of the 2 million kilograms equivalent of conversion. So there's another $70, $80 million there. So you generate DCFs 30 years out for that project, and derive an NPV for the first operation, the first opportunity. And we go through each opportunity in parts and generate the DCFs, the NPVs, and then we sum up the NPVs, and that gives us an enterprise value, which takes in different scenarios for interest rates, weighted average cost of capital, and market pricing, different scenarios for all sorts of different factors that play into that model. But at the end of the day, we end up with a bit of a matrix of values, and we just a fair market value would be somewhere in the middle of all that. So So we've done all that modelling, and I would imagine Cameco's done their modelling. The other part of it is that today SLX is on the ASX, our market cap's 1.1, 1.2 billion. If we do a top-down simplistic valuation, GLE is about 90% of our value today, even probably more, but let's just say 90%. So it's probably around a billion or less, a bit less than a billion of Aussie dollars. If you take out a bit for the cash, you take out something, a little bit for silicon, and anything else that contributes to that valuation, you can end up with a top-down valuation of GLE of around $1 billion US, or 500 million for our 51%. So about half of that for the 26%. So I'm just throwing numbers around very loosely here to give you a top-down and a bottom-up methodology to generate that sort of valuation.
And Michael, what's your expectation of the timing of when Cameco will exercise that option or not?
Well, I wish I could tell you, Andrew, but we have signed a confidentiality agreement on the actual discussions and negotiations.
Right.
And so I can't really tell you any more than that at this point. It's Cameco's options to call, so they control the timing, and we'll just have to wait and see how that plays out.
Understood. That's all good. Look, thank you, Michael. That's been a terrific overview. Look, this is it's an amazing, fantastic opportunity. You know, this revolutionises the whole uranium enrichment supply chain as you prove up this technology. And the blue sky potential here is absolutely enormous. So, you know, we can certainly justify the valuations of SLX just on that first plef opportunity, and with all the other opportunities that come along, and with the royalty streams that come with it, it's you know, the value here is extraordinary. So, you know, good luck with the pilot plant. Hope that that all runs well for you. You get to your TRL6 you know, sometime second half this year, and you know, that's game on. Let's get plef 1 built.
Thanks very much, Andrew. Thanks for the opportunity.
All right, cheers, Michael.